Okay, ladies and gentlemen, I got a couple review pieces, a couple little video things I'll go through. That way, if you're still struggling or just want another couple examples, you just want to kind of look at it, or you just want to make me shut up temporarily, go ahead and make sure you use that pause button. So, couple things. Let's get going with, you have basic probability. Your basic probability is P of A. Now, in theoretical probability, that's usually X out of N, or successes out of total. Do remember that P A bar is going to be the complement of A, or 1 minus P of A. So on a standard six-sided die, probability of 5 is 1 out of 6, so the probability of 5 bar, or the complement of 5, would be 5 out of 6. Okay, now that the boy has his headphones, the probability of getting a 5 and a heads would be 1/6 times 1/2, or 1/12. Probability of a 5 or a heads would be 1/6 plus 1/2, which in this case you'd have to find common denominators. 4/6. Okay, so you'll notice and is multiply or is add. Now, again, we could have a different type of probability. Yes, no, green, black. And if I have a chart something like this, 6, 5, 13, 12, somewhere in that ballpark. Now, of course, I could find my totals here. I have 19, I have 17, I have 11, I have 25. If I want the probability of just yes, then I'm going to be looking at probability of just yes, 19 out of 36. If I wanted the probability of yes and green, it would be yes and green is going to be 6 out of 36. Now, if I wanted the probability of yes, given that I already know green, chances of yes, assuming I already have green, means 6 out of 11. So, a couple little basic probability pieces there. Next, if we did a little bit further review and went with something like out of 12 people, we want to find the first, second, and third prize. Okay, first, second, and third prize out of 12 people. We would need a permutation, which would be 12 choose 3, which means we're going to have 12 factorial over 12 minus 3 factorial. Gives us 12, 11, 10, 9, 1. And that would give us on the bottom, well, 12 minus 3 is 9 factorial, so I have 9, 1. Those cancel out, leaving us just that, which is 12 times 11 times 10. Answer is 1320. 1320 options. Now, if I just said I want a 3-person team, that means the order doesn't matter. First, second, third place. It's still out of 12 people, so it's 12 choose 3. That's going to be 12 factorial over 12 minus 3 factorial, 3 factorial. So I have 12, 11, 10, 9, 8, 1, all over. 9, 8, 1, 3, 2, 1. Gone, gone. Now I would have to reduce further. I have a 3 here and a 2 here. That makes 6, so 12 and 6 cancel out, leaving 2, so I have 110. I have 220. You'll notice combination significantly less than permutation because the order does not matter. All of this comes into play when we start talking about permutations, combinations, and we start talking about binomial probability. Because remember, binomial probability, the probability of n out of r, actually probability of r out of n, excuse me, probability of r out of n, probability of getting 3 right on a 10 question multiple choice test. So if I have 4 choice, 10 question, I want to know what's the probability of getting 3, exactly 3 of those 10 correct. Now, to get exactly 3 out of those 10 correct, I need to use the formula. That formula is going to be n factorial over n minus r factorial, because again, I don't care which 3 I get correct, so order does not matter. That's how all this ties together. Additionally, I say p, that's the number right, so how many did I want right? I wanted 3 right, so it'd be r, okay, out of wrong is q, so that's going to be n minus r. So in our case, we're going to say 10 factorial over 10 minus 3 factorial, 3 factorial, times, now 4 choices means our p-value equals 0.25. And I want 3 of them correct. Q means wrong, so that's 0.75. And if I'm going to get 3 correct, I have to get 7 wrong. So folks, one of the things we always have to look at is these two numbers have to add up to whatever that number is. These two numbers, these proportions have to add up to 1, and the two numbers have to add up to the total. So the whole formula has to match. Now, give me a second. I'm going to run a number on that. By the way, I have a pen from the Environmental Protection Agency in Illinois. So whether it's Illinois and environmental protection, the pen is so green, it has no ink in it, apparently being kind to the environment. Let me find one that works. Okay, here's what I have. I went ahead and worked this out, did a little of it by hand, say 7s are gone, then I have a 3, 2, 1, reduce, 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 reduce. I come up with 120 options. 0.25 to the 3rd power times 0.75 to the 7th power. Put it all together. You'll notice I put it in the calculator, but I put it in as 120 times 0.25 cubed times 0.75 to the 7th comes out 25%. So my probability is only 25%, and that's just for 3 correct. If I wanted 3 or less, I would have to add up the probability of 3. I'd have to do this again for 2. I'd have to do it again for 1. I'd have to do it again for 0. Add up all the probabilities, sum them together. So that's what you're talking about there for binomial. Do remember that in binomial, it's fixed number of trials. Each trial is independent. Only 2 choices, and fixed number of trials independent, 2 choices, and probabilities for us remain equal throughout the whole process. So you have those things. Next thing I'm going to do is I'm going to go ahead and throw up a discrete probability chart. We'll find the mean, standard deviation of that. But before I do, let's take what we were just doing, binomial, and let's find the mean and the standard deviation for binomial. Remember, our p was 0.25. Our total n was 10, so all we have to do is the square root of n times p, which is the square root of 10 times 0.25. I'm sorry, there's no square. It's just n times p. Got in a hurry. Mu equals n times p, so it's 10 times 0.25, which is 2.5. That's how many I should be getting correct. Square root goes with the standard deviation because standard deviation is always a square root in PQ. So I have the square root of 10 times 0.25 times 0.75. If I grab it, put it all together, actually probably easier to see if I use this other one over here. So let's go on clear, second quit, clear mode just for giggles, function quit. Okay, so we have second square root 10 times 0.25 times 0.75. Enter. And you're going to get 1.37. Okay? And again, if needed, you could set it up with a 2.5, go plus 1.37, be 3.87. Minus 1.37, that's going to be 1.13, and then you could keep going twice more to give you an idea for the empirical rule. So that's the idea for binomial. I'll come back, we'll do a discrete probability in the next video.